So first on the agenda is a wonderful design deck from Adam exploring alternate ideas for the data log.
Yes. The basic idea is that we can track the working set directly with a timestamp, and basically ensure that there's no race condition that way, not have the thing grow out of bound the way we would with data log without a mirror, without a window. Casey pointed out that this design on its own might have some issues with multiple destination zones. And just at this very moment, we were I was thinking maybe we could store the zone that rather than having the destinations query each other, we could have the zone. We could have the data sync map store all the zones that it is syncing to in the map, and have those supplied by trim, so that rather than the client side having to coordinate between each other using entry markers, we can essentially have the source keep track of which zone has trimmed what, and get around it that way without having the same kind of storage explosion. Although that's just like as of 10 minutes ago.
Okay, so the basic idea, instead of having a data log, is to just track in OMAP essentially a map of all bucket shards that are unsunk with a timestamp.
Yeah, map of bucket shards to an opaque that we can use to keep things from racing. Yes.
Okay. Right. So this is stored on the source zone where the changes originate, and then there might be multiple destination zones consuming that. Yes. So I guess a couple of different options. One, we could track a completely different working set for each destination, or a single working set where each bucket shard entry or OMAP entry tracks each, I guess, untrimmed zone.
Yes, I kind of lean toward the second. The first one would be easier. The second one would have less write amplification. And I'd really like to avoid introducing more write amplification if possible. But I don't think the first one would necessarily be too bad.
Right. With the first model, if we're tracking separate working sets, then each change would need to write to two different data map objects, although we could potentially do that in parallel. So using OMAP, I mean...
Oh yeah, it's definitely parallel. Yeah, parallelizable.
So I think we might still have concerns about large OMAP if we need to track every bucket shard in the system, even though it is sharded over data log num shards. It could still get large.
We don't have to track every shard in the system. We only have to track every shard with outstanding work. Although I had actually considered although it would be very, very easy at this point, much easier than adding it in later, to add a resharding option so that we can increase the number of shards if we do get large OMAP warnings. I sort of have a design for that in the back of my head. I don't think it would be difficult. I think that would solve any potential large OMAP problems.
Okay. I like that. I mean, the current sharding based on config variables has been kind of thorny.
Do you have a strong... So apart from write amplification concerns, since I definitely agree that it is parallelizable, do you actually have a strong preference for one map per destination? Or, I mean, that might work better if we start having complex bucket policy stuff in the future. or one map that sort of tracks who's who's trimmed. The other issue is you were concerned about priority, and it would be one map per destination would make prioritizing older shards a whole lot less slushy and a lot more firm, whereas with the single map per multiple destinations, prioritizing older unsync work would sort of invariably be much more slushy and much less firm.
Agreed. So, right, one of the issues with just tracking the map of shards is that we don't have an easy way to sort that so that a destination zone can focus on the oldest changes that it hasn't taken yet. And so I think it's important to have some way to represent that. And I think it's going to differ by destination zone depending on what they've consumed already.
Yeah. So that might be an argument for just going the simple route and having one sync map per zone, and that would give us more. Since we can do it in parallel, like you say, I mean, there's really no reason we can't. That would also give us more flexibility for bucket sync policy later on down the line.
Yeah, agreed. Yeah, so on the sync side it's data incremental sync that currently processes data log entries, and it pulls the source zone for the list of changes at a given marker. So we would kind of reimagine this polling as essentially just asking for the next n things to process.
Yeah.
So it would be up to the source zone to sort those.
That wasn't the way I was going to put it. Like, we can only sort by bucket shard because, well, I mean, we can only sort by bucket shard. As far as prioritizing goes, I was going to do that on the client side. We could do it one of two ways. Like, we could, depending on the degree of slushiness that we think is acceptable. I mean, we could certainly have a large window, prioritize the oldest things in the window. Alternatively, we could just have a steady work queue going, and basically just as we traverse the data log set, the oldest n things go in the work queue, and just burn down the work queue. When our work queue's full, we stop traversing. When we pull things out, we start going down the set again, that sort of thing.
So when you say work queue, that sounds kind of like the data log, only we're replicating it to the destination and processing it there. Well,
the work queue, it would still only be a set of shards. It wouldn't be a big pile of entries that keeps growing. And it wouldn't be persistent, since things wouldn't get trimmed until after we do the bucket sync run, or after we do the bucket sync.
So if it's not persistent, that means that each RGW has to read the working set from the source zone and figure out how to prioritize based on that.
Yes.
So why is it better to do the sorting on the destination instead of on the source? Presumably the source could just tell it the next n things to work on if we tracked an index there.
Mostly because we'd have to do even more right amplification to keep track of indices.
Yes. But I mean, isn't there kind of a just algorithmic complexity issue with trying to sort a large number of things if you have to read them all and then do that? It seems like storing them sorted would be worth the overhead of extra OMAP keys.
I'm honestly not sure if I agree with that. I mean, I was thinking we could certainly prioritize things by window, or we could traverse the thing, and we could simply have the top oldest and 100. We wouldn't have to read and sort the entire thing. I mean, the entire question depends on, like, to me, the entire question is more a matter of, we don't necessarily require a strict ordering of oldest first, so much as we want to prevent resource starvation, is my understanding. We want to definitely give the older things a boost in the rankings. So I'm thinking that we could simply, as we go down the set, segment by segment, prioritize the oldest stuff first in every segment, for example. Or we could read a shard and try to do things along those lines.
Okay, I see what you're thinking. In terms of, the main use case, as far as I'm concerned, is disaster recovery. I think it's important to try to minimize how far behind the system is as a whole. And so
that's reasonable.
Trying to be strict about prioritizing the oldest changes, I think, is important.
All right, so we don't necessarily just want to prevent starvation. We actually want a more strict priority. All right, I will see about thinking about that one
then. And this idea comes up with the Rados GW admin sync status command as reporting on whether things are making progress or not. I think it would be a lot harder to tell just based on what's in the current map.
That makes sense. Like, I think I can add a secondary. I can definitely do 2 OMAP entries on the same object with differing prefixes, for example, to do, and I think get something like the priority that you want that way, like within a shard at least.
Yeah.
Across shards, I don't think there's a reasonable way to do it.
Agreed, yeah. And I mean, the way that the data log is sharding kind of has the same behavior.
Although I don't know if Matt's going to be happy with suddenly having to have 2. Well, I mean, they are 2 round trips. If they're on the same object, it happens in the CLS operation. So the write application isn't that bad. So yeah, I don't think Matt would object to that either.
Yeah, but I mean, I'm still concerned about the need to do 1 round trip for every write, which is what the data log window is helping to avoid.
Yeah, but I really don't think there's a way to avoid that. Like, you can't, if we only had 1 sync source, then it would be very, very easy to do the coalescence in RAM. But if we have multiple sync sources, then that brings a race condition back in. And we either end up having to use something like watch notify between the sync sources, or we have to do a round trip. Like, we have to synchronize between them somehow. I mean, the data log sort of gave us an implicit sync between them, but that gave us the write hole in the first place.
Yeah. So currently, each write is calling into the data log twice for prepare and the complete. Can we at least do just the complete?
That I don't know. That would be more a question for someone who knows more about the bucket index log, and that sort of thing. Someone like Eric might be able to answer better. I'm not sure. I basically don't want to make strong claims about safety that I'm not certain of.
Yeah, I don't remember off the top of my head why we need to call into the data log for the prepare.
The prepare is not for the data log, right? The current implementation prepares a bucket index. I don't think there's a prepare for the data log itself. I mean, in the current implementation.
Okay, maybe I'm mistaken, but I was pretty sure that we were calling into data changes log add entry before the index prepare part, and then again after.
So I read the code. So it looks like it's called bucket index prepare, and then bucket index complete. That is it's async, right? Without waiting for the result, we call add entry to the data log. So it happens is a bucket index prepare, and then trigger the bucket index complete, and then it goes away. And then immediately after that, we call add entry to the data log. So I don't see any places that we do the data log prepare or data log complete. So actually, that's caused a lot of troubles because, like, remember, I'm working on that recent condition between data log update and bucket sync and bucket index log update. So there are a lot of problem around that place. I was thinking about add a like transaction to the data log, which means do the data log prepare first and then complete, but it causes more troubles and it doesn't resolve anything. So
yeah, I thought the solution there was right. So we do the bucket index complete asynchronously.
yeah.
I thought the solution was just to wait to write the data log until the index completion succeeds in the background.
Yeah, in that case, like so, we can do it in completion handler to add data log, but that has the crash consistency issue, right? So what if like RGW crashes before we have a chance to add the data log? So it's hard to like satisfy everything.
Okay, I see. Yeah. I was thinking that dir suggest would fix that, but not if the index completion succeeds and the data log entry does not.
Right. So yeah, I was considering many places to solve this, but none of those works well. So I had discussion with Matt. Like Matt is here, like in Bloomberg yesterday. We also talked about get rid of the data log probably. Like, but I haven't got a chance to look at Adam's design doc yet.
Okay, so yeah, it does seem like we would need some kind of transactional support in the data log to resolve that. But that also implies 2 round trips instead of just the one.
And I was thinking, also thinking about if we can so complete the bucket index transaction. If it's not yet, when we're doing the bucket index log reading during the bucket index bucket sync, but that's gonna requires a lot of trips to OSD because the bucket index log doesn't have like enough information. You have to find out the bucket index entry for all this transaction information that requires like a OSD trip. So that's slows down the request to read bucket index log. So that's not a good idea either.
So right, currently we only write BI log entries when the bucket index app completes. We used to write them on the prepares also, but bucket sync just ignored all of the prepares, which was wasteful. So I mean, we could potentially add those back if the destination zone had some way to fix that. But I'm not sure there's a good way to do that.
I was thinking about that too, but that causes some other issues. For example, if we have like a prepare, first of all, it doubles the size of the bucket index log, right? And the second is like when we get this prepare, and then how do we handle that? So we can do this. Of course, we ignore this for the bucket sync, but we need to, based on that, to figure out the bucket index transaction finished or not, right? So, but because of this bucket index is sequential, I'm thinking about we probably go further to find out the corresponding complete.
Yeah.
If we can find the prepare and complete, that can cancel each other. And if we cannot find complete, we can put it into the queue, and another thread will gonna check based on the queue and check back to the corresponding bucket index entry to see if the transaction complete or not. But again, it sounds a solution, but again, there's a crash consistency comes into picture again. Because like we put that in the queue, the RGW can crash, and then that can be lost. And then we don't have a way to check back like for the bucket index transaction.
So right, we're talking about the destination zone here, looking at BI log entries for transactions that happened on the source zone. What exactly would the destination zone do to recover from something?
So Adam's solution, I haven't read through all of this. Right now I have a little bit problem understanding what the exactly mechanism behind it. But Adam, you're proposing like get rid of the data log altogether?
Yes.
Okay.
That was the suggestion. Matt thought it was very important that we not add more write-upification if possible. And the original design of simply supplementing the data log with the current working set basically forces us to do a write per add entry, but we have to keep doing the data log anyway. And it should at least be possible. I mean, it seems pretty possible, depending modular complexity about prioritization, to just record the working set and not have the data log at all.
So the way that I would phrase it is that we're taking the data log and changing it from a queue into a map that basically gets rid of any of the duplicates. We still need some way to order it in terms of prioritization, but the idea is that we're only tracking the set of things that are outstanding. So I think going back to the idea about transactional support for the data log, maybe, I mean, is that really so different than just writing an entry both for the prepare and after the complete?
I don't know. Are you asking me or her?
So like if we add entry during the prepare and in the data log, and then after add entry complete after everything complete, But how do we handle the prepare? Because the prepare could means there's a corresponding complete after that, or also could means unfinished transaction. So in that case, we need to handle these two different cases, right? We need to like keep reading to try to find the complete. If we cannot, and then again, we have to go to the bucket index to find out all these pending transactions there. But it's costly because like if the bucket is very big, we need to go through every single bucket index entry to find out like which one has pending transaction. It's okay for if we do a Rails admin bucket list because it doesn't require a lot of like performance, but it doesn't sound a good idea like during the synchronization, right? So like the I3 request get is if its bucket is very large, it could time out.
Yeah, so I mean, I think that recovery of incomplete transactions should be the responsibility of the source zone, and hopefully we don't need to complicate destination zones and their sync logic with it. I'm just thinking that.
Yeah, I'm thinking about use a totally separate thread, just like we are doing the LC or GEC or a scrub or something to handle that. But in that case, we probably cannot do it like in timely order, like if a lot of because we don't know which bucket has the pending transaction. We probably need to like go through every single ones and with the entire mechanism behind it, multiple threads handle that or something. But we are not able to guarantee it can be done in timely order.
So I'm just trying to think of a way to handle this with the data log and data sync without strict transactional semantics, I guess. So I mean,
yeah.
we rely on the source zone and the dir suggest logic to complete any transactions that haven't. And So the general idea was that we would just write to the data log during the prepare of a write and then write to it again after the complete, so that on the destination side, even if the source crashes, we would be guaranteed to see the prepare at least and potentially pick up the changes from that. But I think there are still some races.
Right. I'm having trouble to figure out like very good way to like recover when we see the data log prepare, and it can be, but if we take the performance or something into picture, it always have some troubles there. The troubles is like for example, the bucket log, if it's a compare, it's a bucket level, bucket shard level, but the transaction pending transaction, it's a bucket index entry level, it's object level or whatever. So yeah, the problem I have is on that part, like to how do we handle it when we see the data log prepare entry.
Are you talking about the source zone itself, looking for things that were prepared but not completed?
Yeah. So
okay.
yeah.
So the right behavior there, I guess, would just be to write a data log entry for the thing again, just to make sure that if there wasn't a complete, that there is one.
Yeah. So what I was thinking about, if we see the data log entry prepare and we don't see the complete, and we offload that, like transaction recover work to a separate thread, and then we add another entry to the data log prepare, so that if that recover cannot finish, we'll have another entry, just like you said. You just said, and so that the transaction recover will be handled like separate from a data sync or bucket sync logic. But as I mentioned earlier, that's gonna have crash consistency issue again, right? And then later on, when we get another entry, data log entry prepared, right? It just we add it later. This could cause a lot of hold on. We shouldn't be that unlucky to get another crash consistency after we see the second entry.
Sorry, where is the crash consistency issue here? Is it just the part that offloads it to a background thread, like
Yes,
maintaining a queue for that?
Yeah, yeah.
Well, it sounds like this strategy implies that we have, so normally the source zone is only writing to its data log. So it sounds like we're adding a thread or something that's also reading through the data log entries that we wrote, looking for incomplete things, right? So whatever's doing that process would I guess track its marker of its position in the local log. And I mean, as long as that marker position was persistent, then after a crash restart, we would start from the same place and identify the same incomplete things. Does that make sense?
Okay, I can think about the details. Yeah, it does make sense to me. Yeah, I was thinking about to look through all this pending BI bucket index entry or bucket index logs, but I didn't think about it to look through entire data log. Okay, yeah, it does make sense. I'll think about the details of that.
Yeah, so I mean, the way that the data log works now with the window thing, data log entries are very detached from, they're not one-to-one with BI log entries, so it's hard to correlate a data log entry with a specific thing in the BI log. Seems like the only real requirement is that we guarantee that we write a data log entry with a timestamp after the BI log completes, just to make sure that a sync of it will see the BI log entry.
Yeah, that's true. But if items, we implemented items solution that would get rid of a data log, then this won't apply anymore. So I wonder if it's a long-term solution, like items designs a long-term solution. We can make the changes on, or the changes we talk about first, and then in the future, when items applied his solution, and probably then we will do it differently. What's the
Yeah,
plan
that's
for
a good
this?
point. I mean,
Yeah.
we do need to think through these races and make sure that his solution accounts for them. But I think that it's really just how we implement the trimming once we sync something that will be able to guarantee or break this guarantee.
Yeah.
With Adam's model, though, it does still seem like we need 2 round trips for the data log versus just the 1. Right, it seems like we need to write something before the bucket index transaction completes to avoid the crash consistency issue. Unless it's possible to write the entry before and not need to write again on complete. So Adam, that's something we'll have to think about in the design here.
Right.
Adam, if you're talking, I didn't hear anything.
I said yes, but I don't know, but I can't speak to the bucket index log at the moment.
Okay. Happy to fill any gaps if you want to discuss on Slack. So I guess what are the next steps or problems to solve in the design?
Well, the next step would just be changing the CLS entry to have more time prioritization, and then finish up doing the REST interface.
Okay, that sounds good. In terms of data incremental sync, there's a ton of complexity there that it sounds like we can avoid by having the source zone do the prioritization stuff.
I believe so,
Data
yes.
sync tracks a cache of all of the things and their timestamps so that it can filter out duplicates and stuff, and we hopefully won't need any of that. Although I think there are going to be some tricky backward compatibility issues between the existing formats and the...
I'm not expecting the new REST interface to look anything like the old REST interface. I was simply going to put a situation up where we have both where people can turn the data, where people can turn them on and off independently. Someone running an old version of Ceph could, for example, run the new sync code, run the new code and the old code at once until they upgrade all their secondaries, for example, and then just burn down the remaining data log. And then once the data log is burned down, just turn off the data changes log entirely.
Okay.
I'm not sure how else we could really do a clean transition that didn't require some sort of flag day.
Yeah, it seems like if you wanted to switch over, you would have to restart from a full sync, which has its own costs.
Yeah, I wouldn't object to forcing that on people, but I don't think anyone would like it.
All right. Yeah, so I think designing that REST interface, I think, is going to kind of inform a lot of the requirements there. The other interesting part, I think, is how the trim works on the other end. Okay, any other thoughts on this? Thanks a lot, Adam. The only other thing on the agenda is one that I added about RGW accounts. I kind of formalized the design doc for the design that had been out there. If anybody's interested, please, you can review in the PR. Any other topics for today? All right. Thanks, everybody. See you next time.